Hello everyone, let's discuss a new problem today. The problem says that you are given three integers a, b and c where a represents n, b represents r and c represent m. And now you have to find and return the value of nCr mod m. Here nCr mod m is equal to n factorial upon n minus r factorial into r factorial whole mod m. Also, you know that what do you mean by a factorial is that you multiply all the numbers less than equal to that particular number and the answer is going to be equal to the factorial of that particular number. Let's say I want to calculate 5 factorial, then that will be equal to 1 into 2 into 3 into 4 into 5. Now, how will you approach this question? So a simple and a brute force approach to solve this question could be that you can simply just compute nCr and divide that result by m, right? Now this solution will work absolutely fine if the value of n and r are small, right? But for large values of n and r, the value nCr will be very large and it is practically not possible to fit it into a variable. Right, so we somehow in an optimized way have to calculate the value of nCr. Now to another way to calculate the value of nCr could be that we can solve this problem recursively. If you remember, you would have studied these formulas in the 12th class. That is, if you want to calculate the value of nCr, you can just simply follow this formula and you can recursively calculate the values. Let's try to draw the recursion tree to easily understand this. Let's say I want to calculate the value of 5c2 and then I can just simply draw this recursion tree and easily get my answer. In this question, you will observe that there are some overlapping problems, right? Here we are calculating the value of 3c1 again and again and making those computations again, and that is adding to a lot of time complexity, right? So here what we did was we calculated the value of nCr recursively and then we did nCr mod m, right? Let's try to further optimize this and see if we can make some better observations. Now you know that nCr is equal to this particular formula and then you have to calculate the mod m. Now, if you remember the modulus property of m, you know that I can actually write this equation in this way also, which basically says that if you have a plus b mod m, you can also write it as a mod m plus b mod m whole mod m, right? And this is what we have essentially done here also, right? Now we saw that we have some overlapping problems present here in this particular recursive tree, and to solve this problem in a better way we can follow the approach of dynamic programming and calculate the value of nCr in a better manner or in a better time complexity, right? So we follow the dynamic programming approach here because we saw some overlapping problems. Now let's see the pseudocode to actually compute the value of nCr in an effective manner. What we can do is we can easily just make a 2D array to solve this problem, and the number of rows will be equal to the value of n and the number of columns will be equal to the value of r, and we can and by traversing the whole matrix we can fill the value one by one in the matrices, and in the end the value present in this variable or in this cell will have the value of n, c and r, and you can effectively, after calculating the value of nCr, can just simply do mod to calculate your answer. Here we are taking with mod m, right? And now what will be the time complexity to solve this question? Since we are traversing the whole matrix, whole 2D matrix, and the number of rows is equal to n in that matrix and the number of columns is equal to r, so the time complexity is going to be n into r. And since we are building a matrix of size n into r, then the space complexity is also going to remain the same. I hope you understand this problem now. Thank you.